Hello and welcome to Funda of Mechanical Engineering on YouTube, and welcome to the second part of the difference between the VCRS and VARS, Vapor Absorption Refrigeration System. In my next lecture, in my last lecture, I described about the VCRS. What is VCRS? What is the schematic diagram of VCRS? And what is the description of TS? How we draw TS diagram and in what process? By combining what kind of processes we composed the TS diagram and make VCRS. Okay, so in this lecture I will describe vapor absorption refrigeration system, but before that I want to recapitulate of previous one. So in my last lecture I mainly described about this compressor, that is mechanical compressor, how we draw TS diagram, and function of evaporator and condenser, and function of expansion valve. So quite wasting time, let me go through the uh, schematic diagram of VARS. VARS, first and foremost, let me tell you, VARS means vapor absorption, refrigeration system. Right, this vapor absorption refrigeration system is known as VARS. What happens in VARS? Actually, the main difference between the vapor absorption refrigeration system and vapor absorption refrigeration system is the compression of refrigerant. The way by which we compress refrigerant in this circuit, in this refrigerant circuit, is the only cause to create difference between the VARS and VCRS. Okay, so let me tell you again and again, the way by which we compress the refrigerant gas into vapor compression refrigeration system by using mechanical engineering, mechanical compression. That's mean where we have to apply work of compression. Okay, and due to this mechanical work of compression, refrigerant is compressed and then it start condensing and circuit is running. Okay, but in case of vapor absorption refrigeration system, instead of using mechanical compressor, here we use thermal compression. Right, thermal compression. This is thermal compression. This is called thermal compressor. Okay, thermal compressor. So how we make a thermal compressor? Let me tell you. In thermal compression, mainly there are three component is main. That is, one is generator where temperature is maintained as GE and heat rejection. Heat given, here we supply heat, that is QG, heat given at T temperature is QG and TG, and here is one absorber where we reject heat, that is QA, and temperature maintained at A. Okay, and this is pump. By this, using a small capacity pump, we create thermal compressor. So let me start with this point. And before further description, I want to tell you that there are two types of absorption refrigeration system. There are two types of absorption refrigeration system. That is, one is water lithium bromide absorption refrigeration system, and other is water ammonia system. Okay, in this system, H2O water is refrigerant, and in this system ammonia NH3 is refrigerant. Okay, you will have to understand. And one thing also that I want to tell you, actually there are two types of solution. Type of solution is used in this process, in this VARS, vapor absorption refrigeration system. One is a strong solution, and another is in weak solution. Why I am telling? Because you will have to understand the difference between the strong solution and weak solution. What is meant by strong solution and what is meant by weak solution? Here is a strong solution, means strong in refrigerant, strong in refrigerant. The solution in which refrigerant is high, rich. Refrigerant is rich, that is called a strong solution, and the solution in which refrigerant is poor, less, that is called weak solution. Poor refrigerant, weak solution. Weak solution. Okay, so this is called a strong solution, weak solution. This is called two types of vapor absorption refrigeration system: water lithium bromide system and NH3H2O system. So now let me describe vapor absorption, main function of vapor absorption refrigeration system. So instead of in vapor compression refrigeration system, we use mechanical compressor to compress the liquid, but here we use the thermal compressor. This is called thermal compressor to compress the process. Now say here is low temperature, low pressure vapor refrigerant gas is enter into this absorber, and from here weak solution at high temperature. That's mean here is also weak solution, low pressure, weak solution, low pressure weak solution is coming into the absorber where it reject heat to the atmosphere, that is QA. Okay, and by combining this weak solution and low temperature, low pressure refrigerant vapor, it goes to the pump, goes to the suction of pump, and it becomes, when this low temperature, low pressure vapor is mixed with the weak solution, then automatically this will become rich solution. Right, because if low temperature, low pressure vapor gas is mixed with weak solution, then by combining weak solution and this refrigerant gas, and this definitely this become rich solution. That's mean increase in the solution which will go through this pump. In that solution, the quantity of the refrigerant will increase. That means automatically this will becomes rich solution. This rich solution goes to generator via pump by creating some amount of work. Okay, so when this rich solution is going into the generator, in what happens in generator, we supplied external heat to the generator to vaporize the refrigerant. So at this point we have high pressure and high temperature refrigerant. High pressure and high temperature refrigerant. Temperature increase due to addition of heat into the generator, and pressure increase due to pump suction. So where high pressure to where suction is created, due to which pressure is increased. Okay, so due to this pump pressure is increased, and due to addition of heat temperature increase. So here in the rich solution, high pressure high temperature refrigerant is just go to condenser. Okay, and again weak solution comes to this way. Weak solution comes to this way into expansion valve. In expansion valve, pressure changes occurs. That's mean here is the pressure PC, that is condensation pressure. Here is the pressure PE, evaporator pressure. Okay, evaporator process. So high pressure and high temperature refrigerant when goes again to the condenser, the same thing happen to the condenser. What happens? It rejects heat to the atmosphere. Right, it rejects heat. By rejecting heat, this high temperature high pressure refrigerant is converted into high pressure but low temperature. High pressure and low temperature. Due to rejection of heat, it becomes low temperature. High pressure low temperature refrigerant liquid. That means here is again gas and here is liquid. This high pressure low temperature again comes into expansion valve, and in expansion valve pressure changes occurs. Okay, pressure changes occur from, actually here is PC and here is PE pressure, and we have to know that PC is always greater than PE. Right, so this pressure changes occur PC to PE, and this here at this point we have low pressure and low temperature refrigerant gas. This low pressure and low temperature refrigerant gas enter into the evaporator, and what happens in evaporator? In evaporator takes heat from the refrigerated space or air conditioning space. It takes heat from the refrigerated space or air conditioning space, and evaporation process occurs. That means this liquid is again transferred into vapor. Low pressure, low temperature vapor. That means this low pressure, low temperature refrigerant is transferred into this low pressure, low temperature vapor, and again this low temperature, low pressure vapor enter into the absorber, and this weak solution comes out from the generator. By combining this, we make rich solution. Rich solution is again suction to the pumps. Due to suction to the pump, pressure increases. Okay, go into is make rich solution. This solution go to the generator. In generator, we add heat from the external source. By adding heat, temperature increase, pressure increase due to pumps, and again this entire circuit is completed. The only difference between the VCRS and VARS is compression process and absorption process. In that, fluid is compressed. In this VARS, fluid refrigerant is compressed by thermal compressor. This is called, most important, you have to know, thermal compressor. Thermal compressor. Why we call it as thermal compressor? Because due to thermal compressor, due to process of thermal compression, we are providing here low grade of energy, heat, low grade of energy. This heat can be rejected heat of any company, solar heat. Okay, so this is low grade energy, basically low grade energy. So this low grade energy is used to drive this compression process. That's why this is called thermal compressor process. And what happens in mechanical VCRS, here is we use mechanical compression. That's mean direct high amount of energy, high grade of energy is used to drive this compression process. So friends, this was the main difference between the VCRS and VARS. If you like this video, then please do not forget to subscribe my channel, which is Fund of Mechanical Engineering on YouTube, and I have come back on YouTube. I will make more videos for you in the coming time. Thank you for watching.